Hello, algebra students. Today we are looking at solving systems of equations with elimination notes, day 2. So today we are looking at slightly more complex problems of solving systems of linear equations. So today's learning target is that we will be able to solve a system of equations using elimination, and that we will be able to state the solution to a system of equations. Since the goal of elimination is to eliminate one of the variables, we need to see whether we can multiply one or both of the equations by a number that would make the elimination of one of the variables happen. So just a reminder that you must multiply all terms in the equations, including both sides of the equal sign. Examples where both equations may need to be multiplied to make one variable eliminate. And so we'll look at these examples here. So example 1. 8x plus 2y equals negative 32, and 5x minus 7y equals negative 26. So when we look at these, least common multiple of 8 and 5 would be 40. Least common multiple of 2 and 17 would be 14. So I'd rather work with 14 than 40. So I'm going to choose to eliminate the y variables. So in order to make these have a 14y and a negative 14y, I'll take a look at the top equation. I want to multiply everything here by positive 7. Okay, and that'll give me a positive 14y. And down here, I'll multiply everything in this equation by positive 2, and that would give me a negative 14y here. So the variable that I'm going to eliminate will be the y variable. So I'll go ahead and multiply everything here by 7. Okay, 7 times 8x will give me 56x. 7 times 2y will give me positive 14y. And 7 times negative 32, 7 times 2 is 14. And 7 times 3 is 21, plus the 2 is 22. So 224, and that was a negative times a positive, so it's negative 224. And then I have 2 times negative 5x, that gives me negative 10x. 2 times negative 7y gives me minus 14y. And then this will be negative as well, because a positive times a negative. 2 times 26 is 52. Okay, so now we can add these two equations together. Negative 56x minus 10x is 46x. 14y minus 14y is 0, so this eliminates. Bring down the equal sign. A negative plus more negatives equals even more negatives. 4 plus 2 is 6. 5 plus 2 is 7. So we get negative 276. Then we divide each side by 46, and that is going to give us 6. Okay, so negative 6, x is equal to, substitute that into either one of the equations to solve for y. So I'm just going to neaten that up a little bit. So let's go ahead and plug it into the second equation. So we have negative 5. Instead of times x, we'll say negative 5 times negative 6 minus 7y equals negative 26. Okay, and negative 5 times a negative 6 is a positive 30. Bring down the minus 7y equals negative 26. Let's get all of our constants together. So we will subtract 30 from each side. This gives us negative 7y equals negative 56. Then divide each side by negative 7 to get y equals positive 8. So we have a solution of negative 6, 8. And then we would check that by plugging in, substituting in the negative 6 for x and the 8 for y in both of the original equations to check for accuracy. Okay, let's take a look at number 2. 10 and 40 would have a GCF of 20. 6 and 7, or excuse me, LCM of 20, and then 6 and 7, 42. So let's go ahead with, let's cancel out the x's. Okay, one's already negative and one's already positive, so that's great. So we just want to get these to 20. So I'll take my top equation and multiply it by 2 to get to negative 20x, and I'll take the bottom equation and multiply it by positive 5 to get to positive 20x. So then we'll go ahead and distribute. So 2 times negative 10x is negative 20x. 2 times negative 6y is negative 12y. And 2 times 2 is 4. Then we'll distribute the 5. 5 times 4x is positive 20x. 5 times 7y is plus 35y. And 5 times 13 is 65. Okay, so now we see that our x terms are all set to cancel out. So we can add these two together. Negative 20x plus 20x is 0. 35y minus 12y, 5 minus 2 is 3, 3 minus 1 is 2, so positive, because we have more positives than negatives, so positive 23y equals 4 plus 65 is 69. 23 divided by 23 is 1, so I have 1y equals 3. So we know our y variable is 3. And then once we have that, we can substitute that into either equation. It doesn't matter which one you sub it into. These are all positive, so I'll just use these. 4x plus 7 times 3 instead of 7 times y equals 13. 7x plus 21 equals 13. Subtract 21 from each side, and we get 4x equals, we have more negatives than positives, and there were 8 more negatives than positives. So then we divide each side by 4 to get y equals negative 2. So negative 2, 3 is our solution. And again, we would check that by substituting in negative 2 for x and 3 for y, and we would do that in both of the equations to check for accuracy and make sure it makes both equations true. Okay, number 3. All right, so when I look at these, the least common multiple of 3 and 4 is 12. Least common multiple of 7 and 3 is 21. So I'd rather work with 12 than 21. Keep our numbers slightly smaller. So we'll cancel out the x's. And they're both positive, so it doesn't matter. But we want to have a 12x and a negative 12x. So I'll take my top equation and multiply it by 4. And I'll take the bottom equation and multiply it by negative 3. So those x terms will cancel out. Okay, so 4 times 3x is 12x. 4 times 3y is 12y. 4 times negative 12 is negative 48. And then multiplying here, negative 3 times positive 12x is negative 12x. Negative 3 times negative 7y is positive 21y. And negative 3 times positive 6 is negative 18. So we can see 12x minus 12x, those will cancel out. Okay, so then I have 12y plus 21y gives us 33y equals negatives plus negatives equals even more negatives. So 8 plus 8 is 16, right? The 6 carry the 1. 4, 5, 6. So negative 66. Then divide each side by 33 to get y equals negative 2. So we have the y coordinate of our term, and then I can plug that into either equation. So I'll just plug it into the top equation and solve for y. So 3x plus 3y equals negative 12. But instead of y, we will sub in negative 2. So 3x minus 6 equals negative 12. Add 6 to each side. This gives us 3x equals negative 6. Divide each side by 3 to get x equals negative 2. Okay, and I think I'll switch to a pen just to get a little bit of a better picture. Okay, moving on to example 4. So we have negative 6x minus 3y equals negative 27 and positive 4x plus 7y equals positive 27. And so probably we'd want to cancel out the x's. So we have here least common multiple of 12 with 6 and 4. The 3 and the 7 would have a least common multiple of 21. So it would be, we'd have smaller numbers. You can cancel out either one, obviously. They'll both work as long as you follow the rules of algebra, but I'm just going to try to keep the numbers small when I can. So if I want to make these into 12x and negative 12x, okay, so this is already negative. We'll leave that as negative and multiply the top equation by 2. That's already positive. We'll leave it positive and multiply the bottom equation by positive 3. Okay, so that'll give us a negative here and a positive here. So then we can go ahead and distribute. Again, that's a negative. Nope, sorry, that's going to be positive because we already have the negative 6 there. So this is just a 2. Okay, so 2 times negative 6x is negative 12x. 2 times negative 3y is minus 6y or negative 6y. And 2 times negative 27 is negative 54. And then here we'll distribute the 3. 3 times 4x is 12x. 3 times 7y is 21y. And 3 times 27 is 7 times 3 is 21, right? The 1, carry the 2. 3 times 2 is 6, plus the 2 is 8. And then a positive times a positive is a positive. Okay, so now we have negative 12x and 12x. These will cancel out. Negative 12x plus 12x is 0. Then I have 21y minus 6y. That gives us a positive 15y, and then 81, I'm just going to jot this down over here, minus 54. It gives us 27. Okay, 27, and then divide by 15 on each side. These are both divisible by 3, so we would get 9, or excuse me, yeah, they're both divisible by 3, so we get 9/5, okay, or 1 4/5. And I don't think that problem is supposed to have a fraction, but we'll just continue going. So 1 4/5 for our y value, and then we can go ahead and plug that into either equation. We'll just use this top equation, so we'll have negative 6x minus 3, and because I see that I'm working with fractions, I'm going to leave this as 9/5 while I'm working with it. The 1 4/5 is helpful when we're plotting the point. The 9/5 is helpful when we are doing the algebraic manipulations here to solve. So I'll write my 3 as the 3 over 1, because I see I'm working with the fraction 9/5. So instead of saying times y, I'll say times 9/5 equals negative 27. Okay, and then I'll bring this down, negative 6x. Negative times a positive is a negative. 9 times 3 is 27, so negative 27/5 equals, and then I see I'm going to need to add like terms, so I'm going to go ahead and make this into fifths. Instead of negative 27, I'm just going to multiply that by 5 to make it fifths, so that's going to be, so negative 135 fifths. Okay, so negative 135 fifths is the same as negative 27. You can use a calculator on this too. I just don't have mine here with me, so I'm going to add 27 fifths. And I got negative 6x, and I'm running out of space here. These are going to cross cancel, equals, that's going to be negative 108 fifths. And again, you can use your calculator for these and use decimals. I'm just going to do the fractions because I don't have my calculator with me. And then I'm going to divide each side by negative 6. Dividing by negative 6 is the same as multiplying by 1 over negative 6. And then remember our divisibility rules from 6th grade. we know that a number is divisible by 3 if the sum of its digits is divisible by 3. So 1 plus 8 is 9, and 9 is divisible by 3. So 108 is divisible by 3. So I'm just going to cross cancel because, like I said, I don't have my calculator. Always bring your calculator, but that's okay. So -2, I'm going to cross cancel by 3. It's going to be -36, okay? And so that'll give me x equals -36 tenths, -36 over -10. So x equals 3.6 because this is 36 tenths, okay? Or 3 and 6 tenths, which would simplify to 3/5. Okay. And if you did the decimal if you did the decimals instead of the fractions, 3/5 is equivalent to 6 tenths, so 3.6, and 4/5 is equivalent to 8 tenths, so 1.8. Okay, and I'll just put a box around both of those, so decimals or fractions, either one is correct. I don't think that problem was supposed to be that complex. So good practice for you to either refresh your memory with decimals and fractions and to check for accuracy as well. So let's go ahead to number 5. 12x minus 16y equals 8, and 3x minus 4y equals 10. So I'll probably want to cancel out the x's. So this is a positive 12x. I want to make this into a negative 12x, so I'll multiply this bottom equation by -4. So the top one, I'm just going to bring it down. 12x minus 16y equals 8. We don't need to do anything with that one. -4 times positive 3x is negative 12x. -4 times -4y is plus 16y. -4 times positive 10 is negative 40. 12x minus 12x is 0. Negative 16y plus 16y is also 0. So we get 0 equals -32. That's never true, so this tells us no solution. Okay. And if you look at the original equations, you'll see if I multiply 3x times 4, I get 12x. -4y times 4, I get -16y. 10 times 4 would give me 40. So they're not the same line, they are parallel lines. So they have the same slope but different y-intercept. So parallel lines, no solution, they will not intersect. Okay, let's look at example 6. 9x plus 10y equals 10, and -4x minus 3y equals 10. So let's cancel out, so 36 or 30. We'll go with the y's, so we'll cancel out the y's. And that's already a positive, that's already a negative, so we'll leave it that way. We'll multiply this by 3. We'll work over here. And we'll multiply that equation by 10. Okay, so, and it's the entire equation that gets multiplied by 10, or by 3 here. 3 times 9x is 27x. 3 times 10y is 30y. 3 times 10 is 30. 10 times -4x is -40x. 10 times -3y is -30y. And 10 times 10 is 100. Okay, so our y's will cancel out. -40x plus 27x, we have more negatives than positive. Counting up 27, 37 to 40, so -13x equals 130. Divide each side by -13, and we get x equals -10. And then once we have our x, we can plug that into either equation to solve for y. So let's do 9 times -10 plus 10 times y equals 10. So -90 plus 10y equals 10. Add 90 to each side. We get 10y equals 100. Divide each side by 10. to get y equals 10. So our y value is 10, and our solution is negative 10, positive 10. Again, we would check by substituting in negative 10 for x, positive 10 for y into both of the original equations and checking to make sure that it makes both equations true. Okay, so that's just a little bit higher level, slightly higher level of complexity of solving systems of equation using elimination. And then we got a little bonus with our fraction practice here. You can feel free to use your calculator to get the decimal approximation, or to get the decimal answers there as well. So solving systems of equations using elimination, day 2.